Hello everyone, Ismail is here. Today we're going to learn how we can use limit and the Riemann sum to find the integration of from the lower limit 1 to 3 upper limit for 4x cubed dx. Now we have 4 steps as I told you. First, to find delta x. Second step, find xi. Third step, I recommended, it's not necessary but I recommended to do it. We find f of xi. Then fourth step, we write the equation limit when n approach infinite, some Riemann sum f of xi times delta x. So now, as I told you, we have 4 steps. The first one is to find delta x. So delta x is equal b minus a over n. Okay? So this is the first one. What's b? What's a? So as you can see, a is the lower limit, which is 1. B is the upper limit, which is the 3. Okay? So we can remember, which is a is 1, b is 3. So now 3 minus 1 over n. 3 minus 1, which is equal to 2 over n. So this one here is my delta x. Now let's find the second step of the two, xi. So to find xi, we use second step. Xi formula is equal a plus I times delta x. A is equal 1 plus I times delta x 2 over n. So now how can I find xi? Xi is equal I times 2, so 1 plus 2i over n. So now this one here is my xi. Now the third step, as I told you, is not necessary but I recommend it to do, which is finding f of xi. So third step, find xi. So what f of x? F of x is here for x cubed, as you can see here. So for we replace every x with xi. Xi is what? 1 plus 2i over n. Now what we need to do, if you remember the binomial theorem, you can expand the bracket by using the binomial theorem. If you don't remember the binomial theorem, so just expand the bracket into 3 different brackets and use distributive property. So I will just say that you don't know the binomial theorem and let's expand the bracket. So now keep 4 times 4 times 1 plus 2i over n times 1 plus 2i over n, 1 plus 2i over n. So 3 to the power of 3, so 3 brackets. Now what should I do? Simplify first 2 brackets, then after that multiply with the third bracket here. Now let's simplify the first bracket. 1 times 1, which is equal 1. 1 times 2in plus 2i over n plus 2i over n plus 2 times 2, 4. I times I squared. N times n squared. Now add the like term. If we go down, add the like term, we have 2ni, 2i. So plan 1 plus 4i over n plus 4i squared over n squared. So all of that multiply with what? 1 plus 2i over n. And don't forget the 4. Now let's distribute this bracket. So now 1 times 1. Okay, let me go down a little bit. So now 1 times 1 is equal 1. Keep 4 outside, it's fine. So 1 times 1 is 1 plus 1 times 2in, 2i over n. Okay, now 4i times 1, same thing, no change, 4i over n. 4in times 2, 4 times 2 is equal 8i squared over n squared. Plus, now do the last one. 4i times 1, 4i squared over n squared. Same. 4 times 2 is equal 8i squared, I cube, because I squared times I is I cube, n squared times n cube. So this one here is my answer. Now before, do I have like term? If I have like term, just combine them together. Okay, let me go down. Okay, so now it will be 4, 1 plus. So I have this one here with this one here. 2 plus 4 is equal 6i over n plus I have also this 8i squared and 4i squared. So 8 plus 4 is equal 12i squared over n squared plus 8i cube over n cube. Okay? You can distribute the 4 or you can just keep it. If you distribute the 4, you'll get a big, high, large number. I don't need to get high, big number. So now let me find it without distributing the 4. Okay? So now this one is f of x I. It's up to you if you want to distribute or not. So now this is f of x I, and we have delta x. So now if we go, what is the fourth step? Do you remember the fourth step that I told you? Is to write the limit. Now limit when n approach to infinite, Riemann sum I is equal 1, n f of x I multiplied with delta x. Now limit when n approach to infinite, I is equal 1 n. Okay? Now f of x I, it's 4 times 1 plus, let me go down, let me remember, what is it? 1 plus, okay, let me copy it from here, 6i over n plus 12i squared over n squared plus 8i cube over n cube. So all of that, okay, let's go back to the question. So all of that is just f of xi. So all of that multiplied with what? Multiplied with the delta x. So delta x is equal what? We already found it, 2 over n. 2 over n. Now I will tell you something. You are free to simplify this, okay, by taking 2n multiplied with the 4 as outside, or you can just distribute 4 for every part, then you multiply 2 for every part. You are free to do whatever you like. So to make the number small, I will take 2 over n multiplied with the 4 as outside to make these numbers small. Okay? At the end, I will just bring them in inside. Or do you want what? Or what? I will tell you what. Let me multiply the numbers and get the big numbers. Okay? And I will do, if we have a time, I will do it with taking outside the common factor. Okay, now let's distribute 4. So now let's distribute 4 for everyone. Okay, limit I equal 1, because I don't need the student to be confused. Why teacher didn't distribute 4? Why didn't distribute 4? So I will distribute it. So it will be 4 plus 4 times 6, 24i over n, plus 4 times 12, which is equal 48i squared over n squared, plus 4 times 8, 32i cube over n cube. So all of that multiplied with 2 over n. Now can I distribute 2n for everyone here? Yes, I can do that. So now let me do it. So limit when n approach to infinite, I is equal 1. Okay? So now let's distribute 2n times 4, so it's equal 8 over n, plus 2 over n times 24. 24, what's the double of 24? Is 48i over n squared. Now, what is the double of 40? Is 80. The double of 80 is 16. 16 plus 80 is 96. So 96i squared over n cube, plus n times 32. So it should equal 64i cube over n to the power of 4. Okay, let's do it again. Let's make sure from our multiplication. 2 times 4 is 8. 2 times 24 is 48. 2 times 48 is 96. 2 times 32 is 64. Now I squared, I cube, n to n squared, n cube, n to the power of 4. So our multiplication is correct. Now the next step, as I told you before, as I teach you, we need to isolate I. Why we need to isolate I? Because if you go up here, So because if I isolate I have to pick one of these. Okay, so I have to pick one of these examples. Okay, so I have to isolate I to pick one of these. And I want to tell you something also extra. It's not only isolating I. If you don't have I in the term, means if you have a constant like this, okay, let me show you here. So if you have a constant, okay, summation, Riemann sum with a constant like this here, okay, if I have Riemann sum with a constant 5, so the answer for this is 5n. You just cancel the Riemann sum and write n, always like this. Now let me give you an example. So if I have I equal 1 n here, and let's say it's 24. So the answer for this is 24n. Okay, another one. So let's say we have, sorry, this is not Riemann sum, this is just scratch. So now if I have Riemann sum I equal 1 n. So let's say example, I have 20 over n. So this one can be written as 1 over n 20, right? I can take 1 over n before the Riemann sum. So it will be 1 over n, take it before. So it will be 1 over n, I equal 1, 20. So now this term is equal what? 1 over n times 20 n. Okay, so now if you have a constant, the answer, you just add the constant to the n. Okay, and if you have a constant with I, only constant with I, so you take the constant before the Riemann sum. Anything before the Riemann sum. Then you replace the Riemann sum with one of these. This one, this one, this one, this one, or this one. Okay, now let's go back to our question. Now, as you can see here, now let's split the Riemann sum. Okay, means let's distribute the Riemann sum. So as you can see here, I have this one Riemann sum distributed for this one, for this one, and for this one. So now let's rewrite it again. Let's use the blue one. Limit. Okay, when n approach to infinite. So first thing, Riemann sum I equal 1 n for 8 over n plus Riemann sum I equal n 48 I over n squared plus summation I1 n 96 I squared over n cube plus summation I equal 1 n 64 over n to the power of 4 I cube. Okay, let me erase this. Now as you can see here, I distribute the Riemann sum for every part. Why? Because I need to isolate I. Now, how we can isolate I? So, as I told you, anything beside I, take it before the Riemann sum. So, we take 64 over n before the sum. So, it will be 64 over n to the power of 4. Riemann sum I equal 1 n. Let's remain I to the power of 3. Okay? Plus, we do the same thing, 96, we take it before the Riemann sum. So 96 over n cube I equal 1 n I squared plus 48, we take it before. So it will be 48 over n squared n, sorry not n, I equal 1, n here is equal I. Plus, so as I told you, this one is a constant, there is no I, so I have to leave the constant with the Riemann sum. So I will pretend this one is 1 over n, so I take it before, so it will be 1 over n, then sum I equal 1, n and 8. Then we write limit when n approach to infinite. So I hope this step is clear. Now what should I do? I replace with every Riemann sum with the formula that we learned. So as you can see here, this part here will be equal 8n plus this part here. Okay, let me keep the blue one first. So 48 over n squared. So this one multiplied with I, if we go up here to see what is I from the table, I is n times n plus 1 over 2. So it's n times n plus 1 over 2 plus, we keep this one, 96 over n to the power of 3. Now, what is I squared? It's n times n plus 1, 2, n plus 1, all of that over 6. Now, let's do this one here, plus 64 over n to the power of 4 times, what is, it should be n squared plus n plus 1 squared over 4. So let's make sure that I get the formula correct from here. So square is this one, cube is this one, which is correct. So both of them are correct. Now we start simplify. Don't forget to write the limit. Okay, so all of that limit when n approach to infinite. Now what we have to do, just multiply the numerator with the numerator, denominator with the denominator. So limit when n approach to infinite, so it will be 8. Oh, sorry, I forget to get this one down. So 1 over n, sorry. Okay, I forget to get this one down. Okay, so now so it will be 8n over n plus, here, this one times this one, this one times this one, so it will be 48n times n plus 1, so all of that over 2n squared plus 96 times n plus 1 times 2n plus 1, so all of that 6n cubed plus, do the same thing, 64 times n squared n plus 1 square, all of that 4 to the power of 4. Clear what I did here? I just multiplied the numerators with the numerators, the denominator with the denominators. Now anything in the numerator you can cancel it with the denominator, but exception, don't touch the brackets. So these brackets, don't touch them, please. These you can't cancel n with the n here, you can't cancel them, no. So anything inside the bracket, don't cancel it. This is not a correct concept of math. So anything outside the bracket you can cancel, anything inside you can't. Okay, so now the first thing, let's start here. So cancel n with n. So now limit when n approach to infinite equal 8 plus 1n with a square. Then we distribute, sorry, before distribute, let's simplify. So 48 divide by 2, so it's equal 24. 48 divided by 2, 24. N plus 1 over n plus. We cancel the n with the n cube. Okay? 96 divided by 6 is equal 16. So 16 n plus 1. Okay? n plus 1. 2n plus 1. So all of that over n to the power of 2 plus 64 divide by 4, I think it's 60, still also 16, so 16, so this one cancels 16, and 2n with 4n, so it's remain only n to the power of 2, n plus 1 to the power of 2. Now let's use distributive property and expand the bracket. So now here it will be, let me go down, it will be limit when n approach to infinite 8 plus 24n plus 24 over n, so we distribute, plus, let's simplify this. So this one is equal n times 2n, it's 2n squared plus 3n plus 1. So now let's distribute 16. So 16 times 2, which is equal 12, so 32. 32n squared plus 3 times 16 is 18, 1 here, 4, so 48 n plus 16 over n squared plus, okay? Now let's expand this one here. So to expand this one, it will be, let me do it fast. So it will be n squared plus 2n plus 1. Okay, now let's distribute 16 for every part. So it will be now 16n squared plus 32n plus 1, all of that over n squared. Now, it's up to you. You can replace n with the infinite, or you can split the denominator with every numerator. So let me split it for you in order, if you don't know how to substitute the n to infinite, approach infinite. So 8 plus 42, sorry, not 42. So we take these two together, 24n over n plus, we take these two together, 24 over n plus, so we take these two together, so 32n squared over n squared plus these two together, 48 over n, it's 48n over n squared plus, same thing, 16 over n squared plus 16n squared over n squared plus 32n over n squared plus 1 over n squared. Now let's cancel every n, the numerator, so n times n. So now 8 plus 24 plus 24 over n plus this cancel this, so 32 plus this cancel 1, so it will be 48 over n plus this one cannot cancel anything, n squared plus this one cancel this, so it will be 16. This one can cancel 1, so 32 over n plus 1 over n squared. So all of that will limit n approach to infinite. Now let's substitute every n with the infinite, and you know that any number over infinite is equal what? 0. So now let's substitute every n with infinite. So now 8 plus 24 plus 24 over infinite plus 32 plus 48 over infinite plus 16 over infinite square plus 16 plus 32 over infinite plus 1 over infinite square. So now, as I told you, any number with over infinite is equal 0. So now this part is equal 0. 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 So now 0 plus 0 plus 16 plus 0 plus 0 plus 32 plus 0 plus 24 plus 8. So now what is the answer if we need to add all of these? So 16 plus 32 plus 8 plus 24, which is equal, the answer is equal 80, which is the final answer. Okay, so I hope you understand this. It's long steps, as you can see here, but you can, let's say, simplify some steps without doing that, because I'm explaining every step to make sure that you understand all the steps. You can just do some step mentally, means expanding brackets or cancelling ends. You can do it mentally. You don't have to follow this one, this one, this one. So you can, let's say, shortcut all of these 4 steps. Okay, but I did here step by step to let you understand what we can do. But you can shortalize all of these steps by doing it mentally. Okay, so this will be the final answer for the question for x cubed. So the answer here, it should be equal 80 unit square. Okay, so don't forget. So I hope you understand this question. If you have anything, please ask me. Have a good day. Bye bye.